Okay, so practice free response questions. This is week 21 and we're looking at a pendulum type situation. Alright, so simple harmonic motion. So the person, first of all, let's just talk about what happens. The person is going to swing, right, on this rope swing, like into the water, and they'd be going fastest down here, right? So their potential energy turns into kinetic energy. And then as they swing back up, their kinetic would turn back into potential. So at point D, if this is the same height, they would have zero speed, right? And then they would speed up, slow down, speed up, slow down, speed up, slow down, etc. Okay, so questions say, starting from rest at point A, a 50-kilogram person swings along a circular arc from a rope attached to a tree branch over a lake as shown in the figure. Point D is at the same height of point A, okay, and 6.4 meters. So let's see. I wonder if we even use that. Ignore air resistance, elasticity of the rope. Okay, person swings 2 times, each time letting go of the rope at a different point. So on the first swing, person lets go of the rope when they're at C, and then for the second swing, they're going to let go at D. Alright, so we're supposed to draw what that looks like, and it looks something like this, where at point C, so notice how the velocity is tangent to the circle right as it starts, and then it goes up and then comes back down. Notice how it doesn't go higher than point D. That would violate the conservation of energy. And then for the second part, when they swing and they get up to point D, they have zero speed at that point. So if they let go of the rope right there, they're going to fall straight down. Okay. Part 2, question 2, or B, center of mass of the person standing on the platform is 4.1 above the surface of the earth. Gravitational potential energy. Okay, so gravitational potential energy we know is mgh. So mgh, and get something like 210 joules. So that's right here at their starting position. 210 joules. Okay. C, center of mass of the person, point B, the lowest point, so 2.4 meters above the surface of water, and calculate the person's speed at point B. So we did a lab just like this, where we are looking at the difference in heights. So in going from this height to this height, they lose some potential energy, which is related to that height. So if you're looking at the calculation where we set potential equal to kinetic, so potential equal to kinetic, notice how there's 1.7, that's the difference in the heights. Solving for V gives 5.8 meters per second, and notice how that would be the velocity right here, and it would be in that direction, tangent to the circle. Question D. Suppose that the person swings from the rope third time, letting go at point B. Calculate R, the horizontal distance they go before they hit the water. So, looks something like this. So this is going back to projectile motion. Something has a height of 2.4 meters above this. It's launched horizontally with a speed of 5.8 meters per second. How far does it go? What's the horizontal distance? So we're going to first find the time it takes to fall a distance of 2.4 meters. Notice how 5.8 does not factor in. The super common mistake is people put 5.8 meters per second right there for initial velocity. No way. This is horizontal. This is vertical motion. So that's 0. That is 0. 2.4 is this. Technically, we would have a negative and a negative here, but they cancel out, so whatever. Solving, we get t equals 0.7 seconds. So if you were to drop an object, it would take 0.7 seconds to fall 2.4 meters. Because horizontal motion, horizontal velocity is constant in projectile motion, we just use distance equals velocity times time. So horizontal velocity, time in the air, gives us a distance traveled of 4.1 meters. From the time, it sounds like a fun rope swing, that's pretty high. Okay. E. If the person does not let go of the rope, How does the magnitude amount of the person's momentum at C compare with the magnitude of the person's momentum at point B? So hopefully you all recognize that they're slowing down, so they're going, let's see, wait, what are we comparing? Point B and point C. Okay, so they're going fastest here and then not as fast here, so they'd have less momentum here, more momentum here, and that's just a simple answer to the question. I think they asked us to provide a physical explanation, so something like, what did I write? Person is going slower at point C, so they have less momentum at point C than at point B. And you could also, if you wanted to add detail, person is going slower at point C because they have greater potential energy, thus lower kinetic energy, thus lower velocity, thus lower momentum. I think that's it. In the next lesson we'll do question 2, which is a little more difficult. Thanks.